Welcome to the DIY Honda Garage channel. In this presentation, we will address Diagnostic Trouble Code DTC P0123, which indicates a high voltage condition in the Throttle Position Sensor A circuit on the 2017 to 2022 Honda CRV. The TP sensor is a crucial component of the vehicle's engine management system, directly affecting the engine's performance and efficiency. Located on the throttle body, the TP sensor provides the Engine Control Module (ECM) with real-time data regarding the position of the throttle. This information is vital for optimizing fuel delivery and maintaining proper engine dynamics. A fault in this sensor can lead to various performance issues, including poor acceleration and increased emissions. Our goal is to systematically troubleshoot and rectify the underlying issues causing this specific DTC. DTC P0123 signals that there is a high voltage reading in the TP Sensor A circuit. This sensor plays a pivotal role in relaying the throttle position to the Engine Control Module. Its accurate readings ensure that the vehicle's engine operates efficiently and responds to the driver's inputs. The TP sensor is usually positioned on the throttle body, which is generally located between the air intake and the intake manifold. A malfunction in this circuit can lead to erroneous signals being sent to the ECM, which could trigger the vehicle into fail-safe mode, resulting in poor engine performance. Understanding the implications of a high voltage condition in the TP sensor is crucial for effective troubleshooting. Several factors may contribute to DTC P0123, which requires careful examination. One potential cause is poor electrical connections, which can interfere with the sensor's ability to relay accurate readings to the ECM. Loose terminals can also lead to intermittent contact, resulting in fluctuating voltage levels that trigger this DTC. Damaged wiring in the circuit could additionally be responsible, particularly if the insulation has worn away or if there are corrosion issues. All these causes necessitate a careful inspection of the wiring harness and connectors associated with the TP sensor and the test point connections. Each of these components is vital in maintaining reliable sensor performance. The presence of DTC P0123 can manifest through various symptoms that a driver may experience. One common symptom is a noticeable decline in acceleration response, which means the vehicle may not respond as quickly or smoothly when the throttle is engaged. Additionally, the check engine light will likely illuminate, indicating that the vehicle's onboard diagnostics have detected a fault. Reduced engine efficiency is another significant symptom, potentially leading to decreased fuel economy and increased emissions. The combination of these symptoms signals that immediate attention to the throttle position sensor and related circuits is necessary to ensure optimal vehicle performance. In troubleshooting step 1, begin by turning the vehicle to the on mode without starting the engine. This action powers the onboard diagnostic system and prepares it for diagnostic testing. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs. This step resets the system and prepares it for a fresh diagnosis. After clearing, check the parameters of the TP sensor A, ensuring that its signal value meets the threshold, which is typically around 4.8 volts. This voltage level is crucial as it determines whether the current signal conditions match the expected readings. If the readings do not match, it may indicate an intermittent failure requiring further inspection. In the second troubleshooting step, check for any pending or confirmed DTCs using the HDS. It is critical to ascertain whether DTC P0123 coexists with DTC P0223, which signals a high voltage condition in TP sensor B. If both DTCs are present simultaneously, this could indicate a shared electrical issue or system fault within the throttle body or its associated wiring. If only DTC P0123 is indicated, proceed to the next troubleshooting step, Evaluating the presence of these DTCs not only narrows down the failure area, but also aids in pinpointing whether the issue is localized within one specific component or across multiple related components. Step 3 requires turning the vehicle off and disconnecting the 6P connector from the throttle body. After disconnecting, switch the vehicle back to the on mode while keeping the throttle body connector unplugged. Next, measure the voltage between test points 1 and 2. Test point 1 is the female terminal number 6 of the throttle body connector, while test point 2 is the vehicle's body ground. This check helps identify if there is around 5.0 volts as expected. If the measured voltage matches this figure, it confirms that the wiring and grounding are intact, and the next step would be to replace the throttle body. If the voltage is incorrect, further diagnosis is warranted. For the fourth step, begin by turning the vehicle to the off mode and jumpering the SCS, service check signal, line using the HDS. After waiting for over a minute, disconnect the PCM, Powertrain Control Module, Connector B, which has 51 pins. Checking for continuity between the defined test points will help isolate any breaks or faults in the THL1 wire. Test point 1 is the same female terminal number 6 at the throttle body connector, and test point 2 is pin number 6, 46 on the PCM connector. If continuity exists, it verifies that the THL1 wire is functioning correctly, necessitating a review of authorized service information for further diagnostics. If there's no continuity, it indicates that one should repair the open in the THL1 wire. The final step involves repeating a procedure similar to the fourth step, yet focusing on the SG3 line, which is another circuit associated with the TP sensor. Turn the vehicle to the off mode and jump the SCS line using the HDS once again. Disconnect both the PCM connector B and the throttle body 6P connector as part of this procedure. The objective is to check continuity between test points 1 and 2, with test point 1 being the female terminal number 3 from the throttle body connector, and test point 2 being pin number 49 from the PCM. If continuity is verified, the SG3 wire is deemed functional, and a further review of authorized service data is warranted. If not, repair any open circuits within the SG3 line to rectify the issues, causing DTC P0123. Once repairs have been completed, it is essential to conduct a final verification to ensure that the problem has been resolved. Start by rechecking for the presence of DTC P0123 using the HDS. If the code is still present, further investigation may be necessary to ensure that all components and connections have been properly addressed. A crucial aspect of verification is to take the vehicle for a test drive. During this test drive, pay close attention to the throttle response. There should be a smooth and responsive acceleration without any hesitation. This test not only helps affirm that the repair was successful, but also ensures that overall engine performance is restored, providing proper functioning in real driving conditions. To prevent future occurrences of DTC P0123, implementing preventive maintenance practices is essential. Conducting regular checks on all electrical connectors associated with the throttle body and TP sensors can help identify loose terminals or corrosion before they escalate into more significant issues. In addition, routinely inspecting the wiring leading to the throttle body will mitigate risks of wear and ensure reliable signals are sent to the ECM. Lastly, performing scheduled system diagnostics can help catch any anomalies in the vehicle's performance early on. This proactive approach is vital in ensuring the longevity and reliability of the throttle position sensor circuit and overall engine management system. In conclusion, DTC P0123 indicates a high voltage condition in the throttle position sensor A circuit, posing risks to the vehicle's performance. Troubleshooting methods involve systematic checks of the TP sensor, its wiring, and connections to the ECM. Identifying possible causes, such as loose terminals or damaged wiring, is crucial in effectively diagnosing the issue. Furthermore, implementing preventive maintenance strategies can help minimize the likelihood of future faults in this circuit. By thoroughly following these troubleshooting and maintenance steps, technicians can ensure that the Honda CRV operates efficiently and reliably. Please like and subscribe to the channel. See you next time.